Welcome back to Good for Sleep, the quiet place where curiosity doesn't have to be urgent, where a question can arrive the way a thought arrives, just before sleep, unhurried, a little loose at the edges, content to be held, without being answered all the way. Tonight's title has a word in it that I want to address before we go any further. It's a dramatic word, the kind that belongs in a headline, not in a bedroom. And the truth is, Venus is not evil. Venus has no intentions at all. No malice, no agenda. It is a planet made of rock and gas and heat, following the same laws of physics that govern every other object in the solar system, doing nothing more and nothing less than what those laws allow. But the word earns its place, in a way, because Venus, when you look at what it has become, is the closest thing our solar system has to a warning. A planet almost exactly the size of ours. Almost exactly the same mass. Born at roughly the same time, from the same cloud of gas and dust, following the same general recipe. And yet it arrived somewhere, so different from Earth that the difference feels almost like a choice. It wasn't, but it feels that way. And that feeling is worth exploring slowly tonight, from wherever you are resting. Let's begin with what Venus looks like from here. On certain evenings, it is the brightest object in the sky after the sun and the moon. You have certainly seen it, even if you didn't know what you were seeing. It appears low on the horizon, shortly after sunset, or before sunrise, depending on where it is in its orbit. Brilliant, steady, not twinkling the way stars do, because it is close enough that it appears as a disk rather than a point, and disks don't scintillate. The ancient world called it the evening star, and also the morning star. For a long time, people thought they were two different objects, one that appeared at dusk, one that appeared at dawn. It took careful observation to realize they were the same thing, following the sun around the sky, never straying far from it. Always one of the last lights to fade in the evening, and one of the first to appear at dawn. It is beautiful. From here, it is only light, only brightness. The clouds that cover it entirely. And Venus is covered entirely, not a patch of surface visible, not a break. In the overcast, those clouds are made of sulfuric acid, but they are also highly reflective. They bounce sunlight back into space with unusual efficiency. That is why Venus is so bright. Not because it is warm, not because it glows with its own light, but because it is extraordinarily good at reflecting the light it receives. Beauty, in this case, is a surface condition. What lies beneath the clouds is something else entirely. Beneath the clouds, Venus is the closest thing to hell that our solar system offers. The surface temperature is about 465 degrees Celsius. Not at the equator. Not in a particularly hot region. Everywhere. At the poles. On the mountaintops. At the bottom of the valleys. The temperature across the entire surface of Venus varies by only a few degrees because the atmosphere is so dense and so efficient at distributing heat that no place is spared. 465 degrees. Hot enough to melt lead. Hot enough that the first Soviet probes, sent to the surface in the 1970s and 1980s, the only spacecraft that have ever successfully landed on Venus, survived for between 23 minutes and about 2 hours before the heat and pressure destroyed them. 2 hours. On a planet that has been there for 4.5 billion years. The atmospheric pressure at the surface is about 92 times that of Earth. The weight of the Venusian atmosphere pressing down on you, if you could somehow stand there, would be equivalent to standing nearly a kilometer underwater. Not at the surface of the ocean, a kilometer down in the deep where the pressure is crushing and the darkness is complete. Except it would not be dark on Venus. It would be a dim orange sulfurous twilight, the thick clouds filtering sunlight into something murky and diffuse. A sky the color of an old bruise, pressing down with the weight of an ocean. This is Earth's twin. This is what the same recipe, applied slightly differently, can produce. So what happened? The answer begins with distance. Venus orbits the sun at about 70% of the Earth's distance. Closer. Not dramatically closer. Not so close that the difference seems like it should matter, but close enough that it receives significantly more solar energy. About twice as much as Earth does. And in the early solar system, when both planets were young and still finding their way, that extra heat may have made all the difference. The leading theory is this. In its early history, Venus may have had oceans, liquid water like Earth's, perhaps even conditions that were not entirely hostile to the chemistry that leads to life. We don't know for certain. The evidence is difficult to find because Venus has been geologically resurfaced. Many times, its old crust churned and replaced, its early history buried. But if there were oceans, they didn't last. The extrasolar energy heated the surface enough to begin evaporating the water, faster than it could be replenished. Water vapor entered the atmosphere. And here is where the story becomes a slow, irreversible unraveling. Because water, vapor is a greenhouse gas. It traps heat. The more it accumulated in the atmosphere, the warmer the planet became. The warmer the planet became, the more water evaporated. The more water evaporated, the more heat was trapped. A feedback loop, self-reinforcing, tightening with every cycle. Eventually, the oceans were gone. The water vapor in the upper atmosphere was broken apart by solar radiation, the hydrogen escaping into space, the oxygen bonding with surface rocks. The water, which might have been the foundation of everything, simply ceased to exist as water. And without water to facilitate the chemical processes that cycle carbon between the surface and the atmosphere, the processes that Earth uses to regulate its own temperature, slowly, over millions of years, carbon dioxide began to accumulate, volcanoes releasing it, nothing removing it. A thick, heavy, heat-trapping blanket of carbon dioxide building over geological time until the surface became what it is now. Not evil, not intentional, just a feedback loop that ran to its conclusion and stayed there. Here is the thought worth holding as you drift toward sleep. Earth has its own feedback loops. The water cycle, the carbon cycle, the slow exchange of gases between the atmosphere and the ocean and the rock. These are not permanent states. They are balances, active, ongoing negotiations between the planet's chemistry and its temperature, maintained not because the Earth intends to maintain them, but because the conditions so far have allowed them to continue. Venus shows us what happens when those balances tip. Not all at once, not in a dramatic moment. Gradually, over millions of years. A slightly warmer ocean here, a slightly thicker atmosphere there. Each change, enabling the next, each step further from the balance, making the balance harder to return to, until the return becomes impossible and the planet settles into a new state, one that is stable in its own way, just not stable in any way that life as we know it could use. The word twin is worth sitting with, because twins begin from the same place. They share an origin, and then the small differences between them, the slightly different circumstances, the slightly different paths, compound over time into something unrecognizable. Two beings from the same beginning arrived somewhere entirely different. Venus and Earth began from the same cloud of gas and dust, roughly 4.5 billion years ago. They are nearly the same size, nearly the same mass. They have nearly the same gravity. They formed at roughly the same time, under roughly the same conditions. And yet one of them has oceans and forests and weather in a pale blue atmosphere and everything alive that has ever existed on any world we have ever visited, and the other has 465-degree sulfuric acid clouds and a surface no spacecraft has survived for more than 2 hours. The difference at its root was a feedback loop that tipped one way instead of the other. The same starting point, a different path, a different arrival. Tonight, Venus is somewhere in the sky. Depending on where it sits in its orbit, it may be visible near the horizon after sunset, or before sunrise, that bright, steady light that the ancient world watched and named and wondered about for thousands of years before anyone knew what it truly was. It is still beautiful from here. From here, it is only light. The crushing pressure and the melting heat and the sulfuric clouds are invisible across that distance. What arrives at your eyes, if you look for it, is only the sunlight it reflects. Bright, steady, almost gentle. There is something in that gap between what a thing appears to be and what it actually is that is worth resting beside. Not as a warning, not as something to fear, but as a reminder that distance changes everything. That what we see from far away is not always what is there up close. That the most brilliant light in the evening sky can be the surface of something we could never survive. And also that Earth from Venus would look much the same. A bright point of Light in a dark sky. Distant, apparently gentle, giving no indication of. Oceans of weather, of the particular, improbable balance of conditions that has been maintained here, without intention, for billions of years. We are the lucky twin, not because anything chose us or protected us or intended for us to be here, but because the feedback loops on this particular planet, at this particular distance from this particular star, happened to balance, happened to hold, have continued holding through ice ages and mass extinctions and geological upheavals. That would seem catastrophic on any human timescale, all the way to this moment. This quiet moment, this room, this breath, this improbable planet, still holding its balance, still maintaining the conditions that make a night like this possible. Venus is out there, still hot, still crushing, still covered in its reflective acid clouds, still bright enough to be the first light you might notice in the evening sky. And we are here, still balanced, still breathing air that is exactly the right mixture, still drinking water that is still liquid, still living on a planet that has not yet tipped into something irreversible. That is not nothing. That is, in the context of what Venus became, everything. Rest now. The balance is holding. It has held all day while you weren't thinking about it. It will hold through the night, through tomorrow, through the long, slow continuation of everything. That makes this planet what it is. You don't have to maintain it while you sleep. It maintains itself. For now, thank you for being here tonight. If Venus gave you something unexpected to rest beside, something that felt less like worry and more like wonder, then this did what it came to do. Come back whenever the night needs company. Sleep gently.